If charge cannot be created or destroyed, how does rubbing a balloon on your shirt make it stick to the wall? Because you didn't do anything, but somehow there's now an invisible force that pulls the balloon toward the wall. Let's figure out exactly what's happening. And before we start, I want to make something clear. This video is entirely conceptual. There's no math, but it will set you up for every single electric topic to come. This all starts with something simple, which is rubbing two objects together. So, for example, if you have a plastic rod and you rub it with some kind of cloth, suddenly it can lift up small bits of paper. We call this static electricity. I'm sure you've heard of it. It's not flowing current, it's charge that's built up on the surface of something. Here's the key. There's only two types of electric charge. One is positive and two is negative. And we know how they behave. Like charges will repel. So if you push a positive battery into a positive battery, it's going to be hard. They don't want to connect. But opposite charges attract. So positive will pull toward negative. But why does rubbing something make it charged? Let's walk through this carefully. So first of all, when you rub the rod with a cloth, it becomes negatively charged. Why? All materials are made of atoms. I'm sure you've heard of atoms. And atoms have three basic parts. They have protons, which are positive and stuck inside the nucleus, which is the center thing. They have electrons, which are negative. They're very light and they can move around. And they have neutrons, which are neutral. When you rub the rod with your cloth, the electrons, which are very loose and tiny, they can get transferred onto the rod. So electrons move from the cloth onto the rod when you rub them together. That's it. That's what charging really is. It's a transfer of electrons. It's not energy. It's not a fluid. It's not a spark. It's electrons moving around. So why is the rod negative? Because the plastic rod has gained electrons. So it becomes negatively charged. And by the way, negative and positive charge simply comes from how we decided to name it. The naming is arbitrary. But this plastic rod gained electrons from the cloth. Some of the cloth electrons moved onto our rod. So it becomes negative. If the cloth here that we were rubbing stuff on lost electrons because they jumped over to the rod, so electron count went down, then what kind of charge is this? It's positive. Nobody created anything. No particles appeared out of nowhere. It's a rearrangement of what was already there. The total charge between these two objects is still the same. It's just that it's moved, and now one has more charge and one has less. This brings us to one of the deepest rules in all of physics. It's the law of conservation of electric charge. So already know conservation of energy. But when it comes to electric charge, it's always zero in total. And the law states that the total amount of charge in an isolated system never changes. It's always zero. So for example, the system of our rod and our cloth that we're rubbing on it. If the rod, let's represent with a number, let's say it becomes -3 charge. The cloth must have become +3. To balance, no matter how hard you rub, the total is still zero. This is not a guess. It's as fundamental as conservation of energy and momentum. And no experiment has ever broken it. Let's go even deeper. Where does this charge actually live? How is it stored in an object? Inside of every atom, let me draw an atom. So that's the nucleus. And we've got these swirly bits. The center, which is the nucleus, it holds the protons, which are positive, and the neutrons, which are neutral or zero. And orbiting it are electrons, and these are negative. A neutral atom has the same number of protons as electrons. But here's the key. Only the electrons can move. The protons are locked inside the nucleus, and they're too massive and stable to shift around from something as simple as rubbing, so friction. So when you charge something, what you're really doing is adding and losing electrons. Because these electrons are light and they're more mobile, it's easier for these to transfer to other things. If an atom gains or loses electrons completely, we call it an ion. So charging is not about adding positive stuff. It's always about electrons. There's either extra electrons or there's missing electrons. Here's an extra insight. On a super hot and dry day, it's actually easier to charge something. You rub a balloon on top of your head, and then suddenly your hair is sticking up because of the static charge. If it's a very humid day or even raining, then what happens? You can still make this charge, but it's very, very hard to keep it. And why is this? You might think that makes sense, right? But exactly why? It's because the molecules that make up water are polar. So they have one end that's slightly positive and one that's slightly negative. So when the air is humid, these water molecules help cancel out surface charge. So that's why on dry days, your body and materials hold on to the charge longer. There's no water molecules coming along and taking your charge. Okay, cool. So electrons can move. They can bounce around and transfer. But in some materials, they move very easily. In others, they're stuck. We split these materials into 3 types. The first type are conductors. Conductors are usually metals, so copper, iron. They have free electrons that can move through the material. So if you touch one side, then the charge spreads out across the entire thing almost instantly. Next is the insulators. Insulators are, for example, plastic, rubber, glass, wood. And electrons are tightly bound to the atoms, so they don't move freely. The charge stays localized where it's added. So if you added charge into it, they won't move as much. For example, a rubber rod. You could rub one side and it stayed charged mostly around this one side. It doesn't spread as easy. And last is semiconductors or semiconductors. And just know that these are the reason why computers work. And I'm not going to go into this. Here's an example to help you visualize these things. Imagine a metal sphere and it's charged. Got static electricity coming off. But you also have one that's neutral. If you connect them with a stick of metal, the charge is going to flow. But if you try a wooden stick, nothing happens. It's not just about whether or not the objects are in contact. It depends on if the electrons inside can move freely. So there's 2 main ways to transfer charge. Let me show you. The first type is conduction. This means touch, so contact. So putting 2 things together. This involves getting a charged object and you touch it with a neutral object. And then the electrons move across. Both objects end up with the same sign of charge. So if your charged object was positive and you put it on something with no charge and neutral, then this thing would become positive too. This is charging by conduction. It's with contact and there's real transfer. The next type is induction. And induction is the cool one because it doesn't require contact to transfer electrons. Let's say you have a metal object that's neutral and you have a metal stick with a negative charge. What happens? If you bring this charged rod with negative charge toward this metal thing with no contact, so there's still a gap between them. Let's move them toward each other. This metal is full of free electrons, right? It's a conductor. The negative rod repels these electrons. So electrons inside your metal thing shift away from the side near the rod. What happens here? Let's zoom in on this square. This is satisfying. So the near side, there's less electrons because they want to move away, right? They get repelled. So that means there's more on the other side and there's less electrons on the near side. That means there's an electron deficit here and there's extra electrons on here. When you increase the electron, negative. This place has less electrons now, so it's positive. So overall, this object still is neutral. The total charge inside this metal thing hasn't changed. However, this charge is just separated. It's differently arranged. Now, if you touch this far side with your finger and you connect it to ground, if you don't know what ground is, don't worry. These extra electrons on this side now have a path to escape out. So they flow out, which reduces the negative charge on the far side. So now this object is still being influenced by this nearby rod. So the near side stays positive. The electrons are being repelled away from that. Now, if you lift your finger or remove this cable to ground, and then you remove the rod, what happens? When you lift your finger or disconnect this side, the excess electrons are gone. When you remove the rod and the positive side is still there, the metal object is now left with a net positive charge. The key principle is that the charged object, so our lappy rod, never touched our object. We never touched it with contact, induction. But the presence of its field was enough to move electrons inside around our object. And then grounding, or putting our finger there, gave these electrons an escape route. So now this object is charged even though we never touched it. You can even cut it in half. one half ends up being positive and one half ends up being negative. This is pure induction. Invisible motion, no contact, but everything obeys the rules. Now what's ground? What was the grounding thing I was talking about? The Earth is basically an infinite electron reservoir. If you connect an object to the Earth, electrons can flow in or out freely through the Earth. Once it's grounded, so for example, our little metal object from before, if we ground it to the Earth, it's no longer isolated. It can lose charge to the planet or gain from it freely. If you unplug it, it's left with however much charge it had at that moment. So if we gained a lot of charge from the Earth and then we suddenly unplugged it, we would have gained charge in total for our object. So to sum up this video very quickly, if you want some notes, electric charge is not energy, it's just electrons moving or not. You cannot create charge, you can only move it, and different materials affect how easily electrons spread and move. You can charge objects by touching, so conduction, or without touching, which is induction. This is the invisible foundation of electrostatics. The next video is about what charge does, so electric fields and how charges push and pull at a distance.